Okay, students, these are our notes for topic 15, sinusoidal functions. And we have two warm-up problems to go over first. The first one tells you that the cosecant of theta is root 6 over 2, and we know cosecant is hypotenuse over opposite, so you can label your hypotenuse and your opposite. Then use the Pythagorean theorem to find the values for x, but because x is on the left, you know that it's going to be the negative root 2. So finally, we know secant is hypotenuse over adjacent, and so the hypotenuse is root 6, the adjacent is negative root 2. When you divide those, you get negative root 3. In the next one, the tangent is negative 3 over 8. Now, either of those values could be negative. You have to look at the picture to figure out which one. But we also know that the cosine's positive. So cosine is positive on the right side, and then the tangent is negative in quadrants 2 and 4. So this is the quadrant that we're dealing with. So I put the negative 3 in the 8, and I use Pythagorean theorem to find the hypotenuse. The hypotenuse will always be positive. When I find the value of sine, opposite over hypotenuse, I get negative 3 over root 73, but I have to rationalize the denominator, and so I end up with negative 3 root 73 over 73. That was a little review from topic 14. So now we're going to talk about graphing sinusoidal functions. Our sinusoidal functions are sine and cosine. Sine looks like a snake, cosine looks like a cup. But notice that when you keep drawing sine or cosine, they look really exactly the same, except one is shifted over from the other. One period of the sine function starts at the midline, goes up, goes back to the midline, goes down, and then goes back to the midline. One period of the cosine starts up, goes to the midline, goes down, back to the midline, and then up. Notice that the cosine function is a horizontal translation of the sine function. Any transformation of the sine function is called a sinusoid, and sine and cosine functions are called sinusoidal functions. A period is the distance it takes for the function to complete one cycle. And in the parent function, the period is 2 pi if we're doing radians, or 360 degrees if we're in degrees. This is the same distance as the circumference of the unit circle. The amplitude is the distance from the middle of the graph to the maximum and minimum points. So in the parent function, the amplitude is 1, from the middle to the top, or from the minimum to the midline. It's a distance of 1. All right, these are some problems that we worked through. The amplitude of a function is going to be the absolute value of the number in front of the sine or the cosine. And then the period of the function, that's how long the graph goes before it repeats, is 2 pi divided by the b number, or if we're in degrees, it will be 360 degrees over the b number. In the first one, the only thing that's changed from the parent function is the 2, and that's going to be the amplitude. So our graph is actually going to look exactly like this one, except it's going to be twice as high. It's going to go up to 2, and it's going to go down to negative 2. The period will still stay 2 pi. So when you're graphing it, you're going to start by finding 2 pi. That's your endpoint. The first thing you do is you mark the midline for the beginning point and the end point. The sine function is midline up, midline down, midline. So we make a midline point at the start and the end, and then one more in the middle. So you just go halfway between your start and your end. Then halfway between these 2 points, you're going to make your up point. And since my amplitude is 2, it's going to go up 2. Halfway between these 2 points, you make your down point. And since my amplitude is 2, it goes down to negative 2. In this problem, the negative is a reflection. So we need to remember that this graph is reflected. For the cosine function, normally it would be up, midline, down, midline, up. But when you reflect that graph, you start low. You start down, midline, up, midline, down. The amplitude is the absolute value of this number, so it's 3/2 or 1.5. And then the period is 2 pi divided by the b number, which is 4. This simplifies to pi over 2. This means this whole shape happens between 0 and pi over 2. So I found pi here, and then half of pi is pi over 2. So this box is showing where my first period is going to land. I have a low point at the beginning and at the end. So I'm marking those, and I'm marking an amplitude of 1.5. So that's my low point to start and my low point to end. Halfway between those two, I have my high point, and so I go up 1.5 from my midline. Then halfway between these two, you have a midline point and then another midline point halfway between these two. Now it looks like if you just look at the dots, you could see how you can connect them with straight lines, but you can't do that. The sine and the cosine function have these curves, concave up, concave down, concave down, concave up. And then the pattern will keep continuing both to the left and to the right. It can be kind of tedious to get all those points in the right place, but you could continue that all the way to the left and to the right. All right, this one didn't seem to have anything new in it, so we went to this one over here. In this one, it's a cosine function again, so it's going to be that cup shape. And the period this time is pi, so the whole graph will happen between 0 and pi. And my amplitude is 4 because of this 4 here. So I have an up point at the beginning and at the end, and so I'm going to go up to an amplitude of 4 at the beginning, and then my period ends at pi, so I have an up point there. Halfway between those two, you have a down point, and then halfway between these, we have a midline point, and halfway between these, we have a midline point. Then you're going to draw in your shape, and it keeps going to the right, and it keeps going to the left as well. It can just be hard to get all those points in. Okay, translations. So you can also translate horizontally and vertically, and if you add a number to the end, that will shift the whole graph up. If you subtract a number to the end here, then it's going to move down. The x's, of course, happen inversely, just like with other functions. So if you have x plus a number, you're going to actually shift left. That's kind of against your instinct. And if you have x minus a number, it's going to shift you to the right. When you shift up and down, that shifts the middle of the graph. So normally the middle of the graph would be at y equals 0, but the whole graph will shift up, which moves the middle of your graph, and that is called the midline. So the equation of the midline is y equals, and whatever that number is in the middle. And it's going to be the same number as you have right here. It's going to be your k value. So we did this problem together. We identified the amplitude was 3. There was no number in front of the x, so my period stayed 2 pi. However, because it says minus pi over 2, I shift right pi over 2. And because it says minus 2, I shift down 2. That makes my midline y equals -2. So when I graph, the first thing I graph is a horizontal line at y equals -2. You should pause the video and graph that. Then I need to move my start point right pi over 2. So normally the start point would be right on the midline here, but I have to move it right pi over 2. So that's where I start. Now when I start at pi over 2, my period is going to be of length 2 pi, which means it's going to end after 2 pi. 2 pi plus pi over 2 is 5 pi over 2. It's going to end over here at 5 pi over 2. And I had to just make my graph a little bit longer to get there. So halfway between these 2 points, there's going to be another midpoint, another midline point right here. And then halfway between these is my up point. Now since my amplitude is 3, from the midline I count 1, 2, 3. And then between these two, halfway, 1, 2, 3. You're going to draw your curve, and just remember that the pattern does keep repeating all the way to the left and to the right. Okay. And I'm going to stop for just a minute, and we're going to pick these up in our next class. So I'm going back to this problem here. I saw you guys do an excellent job with this chart. The amplitude, one sec. Okay, the amplitude is the absolute value of the number in front of the cosine, which is just 4. The period is 2 pi divided by your b value, so divided by 2/3. And before we talk about how to simplify that, I did want to make one point that I kind of missed in your notes. When you're doing the period, if you're in radians, it would be 2 pi over b. But if you're in degrees, of course, it wouldn't be 2 pi, it would be 360 degrees over b. So just make a note of that in, on the second page, that 2 pi over b if you're in radians, but if you're in degrees, 360 degrees over b. I've seen a lot of IB questions are actually in degrees. All right, going back. So when you divide by 2/3, that is the same as multiplying by 3/2. So your 2's cancel out and you get 3 pi. So your period is 3 pi. It's very long. Your phase shift is right here. Because it's a minus, it's going to shift you right pi. And then your vertical shift is at the end, and it shifts you up 1, so that your midline is at y equals 1. So when the whole graph moves up 1, that moves your midline, and the first thing you graph is your midline, a dashed line at 1. So if you haven't graphed your midline yet, do that now. All right, so my graph is supposed to start at pi, and it's supposed to go for a period of 3 pi. So pi plus 3 pi means it would end at 4 pi, and that would be like all the way over here. And I don't have enough room for that, right? So to graph that whole period between pi and 4 pi, there's no space. So what I'm going to do is go backwards. What's pi minus 3 pi? Negative 2 pi. So that means the period before that first period, it starts at negative 2 pi. I don't know why I did a dashed line there. I never did one before. I'll do that. Now notice I use a pencil for that because it's not really part of the graph. It's just kind of the area I'm focusing on. So between negative 2 pi and pi, there's a full cycle of cosine. Now remember that cosine is that cup shape, like that. You have a midline in the middle, and so your points are up, midline, down, midline, up. So I just drew a parent function right there, so I remember what shape is my cosine function. All right, so I'm going to start all the way over here at the negative 2 pi, and I need to start up. My amplitude is 4, so from the 1, I have to go up 1, 2, 3, 4. So that's your first point. It's at negative 2 pi comma 5. Now I don't graph the points in order because I don't always know how far to go for the next one. So what I graph next is I graph the last point. I know the first point and the last point are both up, so my last point is going to be over here and it's going to be up. Between the first and the last point, the middle point is going to be down, so I need to figure out how many boxes they are, and I think you counted them, you told me it was 12, right? So if that's 12 boxes all the way across, I need to go back 6 boxes and then go all the way down. So I'm going to count from my midline down 1, 2, 3, 4, and that gives me a minimum of negative 3. Then between these two, I need to find halfway between these two, so it's going to be 3 boxes, 1, 2, 3, and I should be on the midline. And then between these two, I count 1, 2, 3 boxes, and I'm on the midline. So notice that they're evenly spaced horizontally. Nope, not that either. Sorry, I'm trying to make it a little bit darker without making it all the way dark. Okay. All right. It looks like a V shape, but don't draw a V shape. That would lose you points. You need to have concave down then concave up, and then concave down. Now, even though we say it's a cup, that's just one period of it. It repeats and it looks sinusoidal, which is like it oscillates above and below your midline. So now that I know that my pattern is going 3 boxes at a time, I can continue my pattern. Like that. What questions do you have on that one? Yes?
Why'd you go in the negative direction instead of
I didn't have room. So you have to draw at least a full period. Sometimes the problem will say draw 2 periods of this function. And so if I start at pi and I have a period of 3 pi, it would go from pi to 4 pi. So I didn't have space to draw the whole thing over there. So I backed up to do the period before that. Since we know it keeps repeating and repeating and repeating, you can just do the period that's before that one. Yes?
Why did you put the line on the negative?
Here?
Wait, 2 pi.
Okay, so officially those lines aren't there. They're not like the midline. Like the midline is a nice thing to graph. These lines they're just helping me. So if I did them in pencil, I would want to erase them. But the reason I drew them is because I wanted to know where my graph started and where it stopped for the first period. Okay?
I didn't know which one to put it at.
Okay. Normally, the phase shift tells you where you start. So I would start at pi. And I add the period to it to find out where I end. So pi plus 3 pi is 4 pi. So it should have been between pi and 4 pi. But there wasn't any space for that. So instead I went backwards and I subtracted the 3 pi. So I started at negative 2 pi and I ended at pi. Other questions? Okay, so as you know, this course is called Applications, right? There are a lot of really good applications of sinusoidal functions. So if you turn the page, we're going to do an application problem. Okay, let's focus. You can either be following the words on your own paper, or you can follow them up there. You should not be chatting, though. Sinusoidal functions can be used to model many periodic phenomena in the real world. In some cases, such as the movement of hands on a clock, the models we find will be almost exact. In other cases, such as maximum daily temperature of a city, the model will be less accurate because these things you know can change. The average daytime temperature for a city is given by this function, where T is the time in months after January. So we're going to sketch a graph of this, and even though it doesn't ask us all those things, that's a really good way to organize what you're sketching. So if we look back here, we can write the same words: amplitude, period, phase shift, vertical shift, midline. Amplitude, period, phase shift, vertical shift, and then midline. So often a problem won't ask you those words, but knowing that those are the things you're looking for will be helpful so that you can graph it. There's a lot to keep track of. It's really hard to graph these without some organization. All right, feel free to work ahead of me here because you know these. The amplitude is 5. The period is 2 pi divided by pi over 6. Which is 2 pi times 6 over pi. And notice that the pi's cancel out. Now this actually makes sense because what does the T represent? The problem's about temperature, but I think the T is the time. So T is the time in months after January. So when we talk about time, we don't say it's been like pi months, right? We don't say that. We say instead it's been 12 months. So it does make sense for the pi's to cancel out. Your phase shift, there's nothing added or subtracted in the parentheses there, so none. And your vertical shift is up 20. So I guess it's the D that is the temperature, right? Okay. The midline then is y equals 20. So I'm going to start by drawing the midline. Oh, it is 10. Thank you. It looked like a 20 to me. let me start with a different color then. Oh, I'll just exit out. Not that. 20. Sorry, did you guys see 20 is actually up here? Okay. All right. What else do we need to know? We need to know the amplitude. We got that. And there's no phase shift, so I think we're ready. Oh, our period is 12. So the whole graph will happen between here and here. All right, it's cosine again. So cosine is still the cup shape. So it's going to start above the midline. And it's going to end above the midline. My period is 12, so my start is here and my end is here. Halfway between those is going to be your low point, 15. And then you're going to have to estimate halfway between these to get your midline point, and then here too. You do have to make midline points. Okay, and then sketch in the shape with the correct concavity. And then you are going to want to continue that function as well. So that was up, and then it's going to be midline, down, midline, up. Okay. The timing of this one is a little bit weird because you would think that May would be the 5th month. It is actually the 5th month. But it says T is time in months after January. So that means that in January, T equals 0. So if T is 0 in January and not 1 in January, that would actually make May T equals what? How many months after January is May? 4 months later, yeah. So, I mean, it's a little weird because a lot of us, like if your birthday is in May, you know that May is 5, right? But this is talking about January being time equals 0. So May is time equals 4 months. And 4 months is not exactly on here. Sometimes they're going to ask you questions that are just on the graph, and you can just find them. Like if I asked you the temperature when T equals 6, you could just find it. Or if I asked you T equals 9, you could just find it. But it's not too hard because we have a formula and we have a calculator, and so we're just going to evaluate it. So here's my D of 4 equals 5 cosine pi over 6 times 4 plus 20. All right, for this problem, what mode should we be in? Radians. How can you tell it's radian mode? Because of the pi. Now, radians don't always have a pi on them. They do like 95% of the time. A radian measurement will have a pi, but you'll know it's not a degree if it doesn't have a degree symbol. So degrees have to have a degree symbol. Radians, sometimes will say radians and sometimes won't say anything, okay? So radian mode, calculate it. And then do 3 sig figs and compare with the neighbor. All right, are you guys getting 17.5? Okay. All right, last one says find the minimum average daytime temperature and the month it will occur. So this we can find from the graph. Looking at the graph, what is the minimum temperature? 15 degrees. So min temp of 15 degrees happens in what month?
July. You scroll.
Can I scroll? Yes, I can scroll. Yes, so you guys are right. It's when time equals 6. And you would think that would be June, but no, because of our weird counting. January is 0, so then 1 would be February, March, April, May, June, and July is 6.